Every day, millions of essential workers risk their safety enforcing COVID regulations to protect us. Our design proposes to implement an autonomous mask checker in high-volume areas such as airports and other centers of public transportation. This design will use AI to determine whether someone is not wearing their mask properly, or incorrectly wearing their mask. In each of these cases, our design will perform different tasks, such as giving audio reminders, dispensing masks, or showing visual cues. Additionally, our design is designed to be environmentally conscious. The initial prototype features repurposed recyclables, and our final software has many energy-saving components.
As I'm walking by with a mask, the green light turns on because the system detects me with a mask. So now, as my mask is worn incorrectly, a red light turns on, showing me I need to put on my mask correctly. As I put my mask on, the red light turns off. This is the PIR sensor that will detect if there's a person walking by. So as I'm walking by, the camera turns on, sees me without a mask, the light turns on, and the conveyor belt delivers me a mask. Then the signal will output a high-pitched beat to remind the user that they need to put on their mask properly. This will play continuously until the user puts on the mask. When the user puts on the mask with mask routine continues and the green light turns on.
Well, for this project, we have a lot of different hardware components along with some software. In our hardware, we have a lot of different sensors such as the camera feed and the infrared sensors. This feeds the data into our Raspberry Pi, which then communicates using serial ports with our ML backend. This backend was built using Python, and it's essentially a YOLO computer vision model. We built it over many different iterations. And finally, a bit more on the hardware components. We designed and CAD'd all of them, and this includes both for like the storage holding mechanisms, along with the more automated distribution mechanisms for the masks. The biggest challenge we faced during the hackathon was definitely related to communication between the Raspberry Pico Pi and the ML program. This was a very necessary component as the Pico Pi was just computing way too many things and needed way too much power to continuously run. The communication done was way harder than we thought as well. We originally thought about just creating intermediary text files between the two, and then even tried to manipulate the files directly outside its directory for the Pico Pi to then read, but none of those really worked. We finally used the serial connection to remotely modify the Pico script, and that worked, but it definitely used a lot of time.
Now that we have a physical prototype design, our next step is to prepare the model for commercial use. We want to minimize the number of false reports so that people are not wrongfully accused, therefore we need a bigger training set. Therefore, our hope is to send our model for small-scale testing, so that way we can also obtain a bigger training set for the algorithm. Eventually, the model could also be used for larger-scale testing, such as in airports and train stations. Since the mask dispensers are different for each building, we must ensure that the hardware is industrially accessible, mass producible, and flexible to accommodate a variety of mask dispensers.